What's up guys, welcome back to our LS2 rebuild. We've got all our stuff back here from the machine shop and we're ready to get this engine back together. So where we left you after the last episode, we've just done a whole heap of cleaning up, cleaned all the piston ring grooves, cleaned up all the pistons, everything we were getting reused. Our heads have been completed by Tremaniac or Next Gen Engineering. They look amazing. We are stoked with these heads. The flow results of this port are pretty good as well. We're pretty stoked with that, so we are super excited to see just how these heads perform with the cam that we've chosen. Really nice looking heads. I love what they do with the ends of them. A little machining, a little CNC work they do here. Looks incredible. So stoked with these, they're going to be awesome. We've got our block back from the machine shop. So we get the machine shop to do a complete hone as well as install new cam bearings while they've got it and a complete hot wash with all of the plugs removed. So we get the machine shop to do the hone work just because the actual machine shop hones are far superior to doing something like a handheld drill hone. Not only do you get a far better finish on the hone, but the machine shop hones can actually check for round as they go. So it's a much better result. So it's what we do to all our customer engines that we build. We send them to the machine shop to get honed. So while they're at the machine shop, we also get the machine shop to do the cam bearing install, just for the fact that it's a very, very annoying job to do here. We do have the tools to do it, but to actually do it and then check the cam bore is quite difficult. So while it's at the machine shop, we just get them to install the cam bearings and go ahead and check the cam bore because it is just value for money, much better while it's there. So that, as well as the hot wash, we get them to do the hot wash as well. Once again, it's just better value for money for them to do it while it's there. It's not a super expensive thing for them to do, and the block's already there for hone work and getting the cam bores done. We've also got all our fresh parts to go into this engine here, which we'll go through as we install them and put it back together. So you'll see this thing is getting one of our complete stage 2 onsong performance cam kits. We've gone with the cam that we thought would be the best power and drivability balance for a street car, especially being a manual this thing. So pretty keen to see some results from this cam with these heads. We think it's going to be really great. The only thing we've still got to order is push rods, which is one of the reasons we need to get this thing together today so that we can measure the push rod lengths and order the push rods. We are pretty certain that it will just need standard length push rods from so many cam kits that we've done before. We've got 30 thou taken off these heads. So that's why we're just going to check, but usually when we get that much taken off the heads, using a Crow Cam's cam, the base circles on them are usually pretty spot on, and we do find that usually a standard length push rod is absolutely perfect, gives us the perfect amount of preload. Anyway, first things first is to give the block a nice big clean up, bottle brush all of the oil galleries, give it a nice big clean, you know, hot washes to get a lot of the caked up oil and stuff out of it that may have built up over the years, but due to it having been in a machine shop environment around swarf and that sort of thing, it's always really important to do a final wash before assembly. Alright guys, so my apologies to anyone who's watched us put together the millions of LSs that we've done on this channel already. You're probably going to hear a lot of recycled information, but there's just so many key little things with the LS that are just so important that I feel the need to repeat them for anyone who may be new watching. So my apologies, but we're going to go through it basically from start to finish as if everyone's a new viewer anyway. So let's go. Engine room's an absolute mess at the moment because we've got so much stuff going on, so just want a quick little tidy up.
That stuff for
make some room up in here. Yes, this is what I'm about to talk about. So, first things first, torque to yield hardware. Now, just about everything that's used on the LS is a torque to yield hardware, which means it is designed to only be used a finite amount of times. It's only meant to be tightened a few times. So, what we generally do, particularly with customer engines like this that we plan on sort of making a decent chunk of power out of, we always use all new hardware. So we sell this stuff on our website. We've got new rod bolts and new main bolts, as well as new head bolts. For this particular engine, we're actually going to ARP head bolts, but we'll get to that a bit later. But so we've got here new rod bolts, new main bolts. Now, you know, you can get away, we do it on our own engines every now and then, we'll reuse, you know, mains and rods. You can get away with it if you're willing to take the risk, but like I said, for something like this, pretty high tier build for an NA engine, at least for a customer, we always just go ahead and replace it all just for peace of mind. Alright, checking a bit of ring gap. So for this, we chuck the ring in the bore, scoot it down with a piston, make sure it's square, check out some feeler gauges.
Because we're too cheap to buy proper ring squaring tools.
Yeah, we probably should buy one soon. But this is the way we've done it for eons, and it's always been fine. So we always check top ring, second ring, as well as the oil control rings, make sure that they have enough clearance as well. We always like to have our second ring around 1/4 hour bigger than a top ring to prevent ring chatter and stuff like that. And yeah, so begins the process of just doing all the top rings, all the second rings, all oil control rings, and cleaning them all up. Cleaning up all the edges, getting them all spotty dog. Usually we do this outside of the engine room as well, because we don't like doing anything abrasive inside the engine room. So anyway, we'll do some measuring up, figure out which one's going to need some work, and then we'll actually do the grinding outside of the engine room. Alright, so a little bit of a development, not the first time that it's happened, but the standard size rings that we've been sent with an LS with I suppose a few hundred Ks and then a hone, they're just a little bit too big, the gaps are a little bit too big for our liking. We work to like a rule or a ratio, and they are about 25% bigger than we would like as far as the ring gaps go, which for an aspirated engine, it's just not ideal, you know. They'd probably be alright to run, but we really want to make sure this thing's perfect, so we're going to go ahead and order a set of 5 thou over rings so that we can file fit them properly, and we'll have to wait for that. So the bottom end will go on pause for now, but we'll go, what we were originally planning to do is to get the cam in this thing tonight so that we can get the top end all together and get all our, or at least get an idea of our rocket gear and everything together so that we can check what sort of pushrod length we need to order so that we can get those ordered. So if we order our rings first thing in the morning, make sure we order our push rods and everything else we need to finish this off first thing in the morning. It should all still be here by the end of the week, and we can still get this thing sorted ASAP. Alright, so to get as far as getting our push rod length, we have to get our heads together. First things we need to do, because these valves have been ground, is check our installed heights of our new springs to make sure we don't need to shim them up to get the installed heights correctly. To do that, we use this tool. It's a little tool for checking your installed heights. Great little tool. So our tool goes over the valve straight onto the valve spring seat with no stem seal or seat installed. Then the locks go on with the retainer. Now we're careful to record with the retainer where the actual tool sits in relation to where the retainer sits, because they are a dual spring retainer. They have a few steps. So what we worked out is the tool sits on just between this first and second step, which then, if you take into account where the locks go as far as the outer spring, and then that extra step, we have to take 50 thou off our measurement to account for that extra step there. And then our valve stem seals, which incorporate the spring seat in them as well. So this is the spring kit that comes with all of our cam kits. Pack dual springs comes with these valve stem seals, which are the hat type, which are the spring seat as well. So we have to remember that this is going to add 40 thou as well, the spring seat. So we just keep that in mind while we do our measurements and work out whether we need to shim these up to get our installed heights. Alright, so done a measurement on our first valve, and we've ended up with it's going to require a 30 thou shim to get to our installed height of 178. Where it sits at the moment, it's at a 181, so yeah, 30 thou shim will get us to 178 installed height, which is correct for the spring. So we do this for every valve, for every engine that we do. Right, on the intake valve,
like maybe 2 thou different.
Yeah. So if you think it looks really time consuming, it's because it bloody is. But it's not too bad, because once you get a marker or a feel for where this tool needs to be, for you to be sort of where you need to be on your shim, or what shim you need, it starts to get a lot quicker to read. Once you've done a fair few of these, you can see on the tool where it needs to be and whether it's going to need a shim or not, just by looking at where the tool is. So it makes it pretty quick to run through a head sort of thing. You don't have to do this math for every single one. We just did this to show you how we work this out. And CNC heads look so good. It's almost a shame to hide them. So this head's all good. We've got 30 thou shims on every spring. It's a good thing about CNC jobs is that they usually come out dead consistent because they are machined. You know, they're automated. It's not like a hand valve lap job or something where it can come out very different. So 30 thou shims on all springs. We'll go ahead and install our valve stem seals and get this head together. Alright, one head assembled, springs, shims, valve stem seals, valves, locks, all the works.
All the good stuff.
Ready to bloody go, mate. So because we're on a bit of a time limit tonight, or not so much a time limit, but we just don't want to be here until midnight, we're just going to put the one head together for now. We'll do the other head later on, but we just need the one head together to measure our valve.
We only really needed one cylinder, but while we're there,
we only need the one head together to measure our push rods. So now it's time to get the cam in. Now that we've got some bench space here we can use, we're really going to get this place sorted out a bit more. But hey, we'll get there. So got some cam specs. Show you the cam we've chosen for this particular application. So the cam we chose for this thing is just an off-the-shelf cam. It's just a crow grind off the shelf. It's the 1250, which I'll show you the cam card now. So you can see there, 236, 242 on a 113. And you can see there, got 606, 608 lift, so, you know, close to 610 thou lift, which is perfect for what we want to do. So we reckon this will be a really good cam coupled with some nice CNC ported heads for a street car that's a manual. So that's why we chose this cam. We didn't want to go too big, too aggressive, because we didn't want it to be, you know, annoying to drive. You can really screw this up bad enough and make your car really, really annoying to drive by putting a cam that's way too big in it. The other thing that helps this thing out quite a bit is I'm pretty sure it's already got 3 9s or 4 11s. Can't remember, it's one of the two. It's already got some really, really short diff gears in it, so that helps out quite a bit as well. But we just reckon that this cam should make really good power through these heads, and we reckon it should still be just a pleasure to drive with the 6-speed in it. It's actually the same cam that we've got in my drift engine for my drift car, which is still not in the car yet. And yeah, it's not the sort of cam that we put in a daily driver or anything, but for something like this is just going to be a weekender. It should be a really, really nice stick. So because we're only putting the cam in now to check the push rod lengths, we're not going to lube it up or clean it up or anything. We're going to leave it coated in what it's coated in, just put it in dry, and because it's going to come back out anyway. We'll worry about cleaning it up properly and putting our lube on it and everything when it goes in for its final time, which is not now. And a little trick for those playing at home, water pump bolts, same thread as cam gear bolts, so use these, thread them in there, and you got yourself a nice little handle to hold your cam while you put it in. Alright, new head gasket, lifter buckets, new LS7 lifters, all to go in for measuring purposes. So we measured with the stock push rods, and with this combination we've got about 55 thou preload on the spring, which is what we like to see. Seems to be with engine builders a very personal thing. Some engine builders don't like seeing any preload. We like to see somewhere around that 50 to 60 thou personally is what we like. But yeah, that's awesome. That just means standard length push rods are the go. So we'll order some of them tomorrow, but in an 80 thou wall is what we're going for this thing. 80 thou wall push rod. Yeehaw! So we'll order some of that stuff and we'll get this thing together properly later on in the week. I'm actually a bit happier about that because this SD card was nearly full. That's why the clips are getting a bit short. But seeing as that's all we wanted to do tonight, we'll just show you exactly how we check the preload or the lash on an LS. So we check it with the lifters dry. In this instance, the LS lifter is designed to pump up to take up some lash. It doesn't pump up. It won't pump up harder than what the spring pressure has on the lifter, sort of thing. You know, they don't expand a heat with oil or anything. It's just designed to take up the lash. So doing them dry is pretty good. The one thing we don't do with them dry is our piston to valve clearance. We always make sure we have a solid lifter in there for piston to valve, because you need to ensure you're getting potentially exactly how far the valve might go out. You need to account for the extremes. So, but for this is fine. Now your thread pitch for this bolt is a 1mm thread pitch. So that means every single one turn around is 1mm in height, or about 40 thou. So what Rex just done there is tightened it up finger tight until he was pretty much couldn't do it up anymore finger tight. The rocker has now sort of sat on top of the valve. It's hard on the push rod and the top of the valve. And now we're just going to go down and see how many turns around it goes until it bottoms out on the thread. So we've got one turn there, it's about 40 thou, plus, well, let's see, we've got there around about a third, just under a third of a turn. So 1 1/3 would be 60 thou. So we call that about 155.
It's a 55.
Yeah. Yeah,
1.5 is 60.
So yeah, we call that about 55 thou, which for what we like to do with these things is exactly what we like to see. And that is with crow cams. Like I said, guys, our experience with crow cams is that the base circles of all these cams seem to be very consistent, and we do find consistently that we are using standard length push rods with these cams. And usually with our heads going to a cam this size, we normally take off between 30 and 40 thou. You know, as you go bigger in your cam, tighter on your lobe separation, you start to drop that dynamic compression. You really want to get some help off these heads to get some compression back into these things so that you can make the most of the power. We do have fly cutting tools for if we do need to fly cut. We aren't afraid to fly cut these things to get compression back in them with a big cam. For this particular combo, I chose to get 30 thou taken off these heads. The reason being is that when John actually originally approached us about doing some work to his Maloo, his original idea was talking to us about supercharging it. So I didn't want to take too much off so that he wouldn't be afraid of supercharging it in future. And I figured 30 thou with this cam combination should be plenty for this thing. And we shouldn't have any piston and valve issues with this cam. This cam is pretty safe as far as piston and valve goes. And this combo should be all sweet. So now we've just got to order a few more things, get a few things here to get this thing finished off, and get it back together. Sorry guys, should probably add on to that last bit is these are 243 heads, so they start with a smaller chamber than a 241. So that's why I didn't go to 40 thou and then went to 30 thou, just because I have a smaller chamber to start with. So that is the reason. They probably would have been fine at 40 thou. It really probably wouldn't have been an issue even if we did decide to boost later on down the track, but it's just me. Righto guys, so we finally received our new rings for the 6 litre, which are a 10 thou oval, which we can actually properly file fit to the exact gaps that we require. So just gapping them up now. Rex is out here outside of the engine room. We try and do anything abrasive like this outside the engine room. And this is our little ring filer. So it's just a little, pretty much a file stone, which you put rings against and, as the name implies, file them down to get the desired gap. We use a drill because we're lazy, or innovative, whichever one you want to put it.
It's a lot cheaper than an actual electric ring filer.
Ring filer, yeah. So this allowed us to get the proper gaps that we really want, which is important, particularly with aspirated stuff.
Much nicer. I'm much happy with that one.
So the first set, the top ring just chucked in the ball with no filing at all, was like 22 thou, between 22 and 24 thou gap. And these ones we can actually file to 18 thou, which is what we want for this engine. So much better with these. Now after we do the filing with the drill and the stone, we use these little hobby files, these little tiny files, to clean up just all the, I don't think the camera's going to focus on that, but we use these files just to clean up all the edges of the rings. There's a few things when filing rings that you got to be very careful of. Firstly, you always file towards the inside or towards the piston side of the ring. That way if it leaves a dag, it's on the piston side of the ring groove side, not on the bore side. Because if you leave a dag on the ring on the bore side, it's going to drag it up and down the bore and ruin the bore. But we use these either way to make sure there are no dags. We give all of the little ends of the rings where we file a little chamfer, make sure there's no dags, no swarf, nothing left on them like that can catch anywhere. Anyway, it's just little attention to detail, things like that, which make all the difference. So we do that with all our engines that we file rings for. Anyway, once again guys, like I said at the start, sorry for all of you who have watched us put together a heap of these engines and getting all this rehashed information, but again, a lot of people, this is new info.
This is one of my least favourite tasks of building engines. I don't know why, but I get no enjoyment out of filing rings. I just find it tedious.
It is very tedious. It's very, very, very time consuming, but it is one of the most important parts of putting the engine together. So anyway, I'm not going to film the whole process because I'm not going to put you through that, but you do this on a V8, 32 times, including the oil control rings. Usually we don't have to file the oil control rings, but you do have to check them because you do have to make sure that they do have enough gap. Because if not in your oil control rings, but you're going to get terrible oil control, you're going to get heaps of burning oil and just it's going to prematurely wear the bores. It's not a good thing. You really do have to actually make sure that the oil control rings are right. It's something that's overlooked by a lot of people. So anyway, we'll slowly work through this. So, finished up all our ring gaps yesterday. Rex has got the second head together, mostly, except for, as you can see, we've left one cylinder with no springs there. The reason for that is so that we can degree our cam in with our soft springs. and do a few checks with piston and valve clearance and stuff like that before the engine actually gets assembled. So not that we're worried about piston and valve with this particular engine and cam combination.
I'm gonna measure it anyway.
Yeah, with how much we took off those heads, but we're going to measure it anyway. Yeah, we're in the process of pretty much doing a piston to valve check with every cam and head combination we do lately, just to get data together so that we can sort of come up with a surefire measurement, so that we can always tell by just cam specs whether it's going to have piston and valve issues or not, because there's a lot of misinformation about there about what hits and what doesn't, and people worry about piston and valve when they don't have to. So we've decided we're going to start getting a lot of data from anywhere that we can, so we can put together a complete data sheet of what's going to have problems piston and valve based on cam specs. But anyway, with all the ring gaps and stuff done there, as you can see, on their rings ready to go. Obviously you do ring gap to a bore, and each ring that you gap stays with that cylinder. So you gap them to the cylinder that they will be going into, because they can differ just ever so slightly. So after that, it's time to move on to bearing clearances. So this is arguably the most important or imperative part of building an engine. Usually for something like this, where you're putting standard size bearings back in something that's just a standard crank and everything else, is usually fairly straightforward, but nonetheless it has to be measured. Every single clearance has to be measured either way. On some of our own engines, when we're in a big rush or something like that, or we don't particularly care about what we're doing, we will just sort of check one or two and then toss them in and go. But you're always taking a risk doing it that way. It's only if you're in a big hurry. For things like this on a customer's build, every single clearance has to be checked and documented, and blueprinted is what we call this, is blueprinting an engine, which is checking all of the clearancing and doing the ring gap and everything else. Now these all have to be checked, because the consequences of a bearing clearance being too tight means that you're not going to get enough oil flow through the bearing, which means you're going to get too much heat. So not only is oil a lubricator, but it's also a cooling agent. It's really important for cooling the bearing surface and the journal. So if there's not enough oil getting through because the bearing clearance is too tight, you're going to get way too much heat. And too much heat is a very bad thing. That's how you end up picking up a bearing or spinning a bearing, which is no good. The consequence of having the bearing tolerance too loose, or the clearance too loose, is that you will have too much oil. You won't have very good oil pressure because you'll have too much flow. Not only that, but you also have lots of movement, which can also be a very bad thing. So this is just another one of those very long, tedious processes, which is super important and has to be done. For doing these bearing clearances, particularly on something like an LS, where we use the old main bolts and old rod bolts to do up the rods and mains to check the clearances. So we use the old ones so that when we put it together for the final time with the fresh bolts, they're all on their first use, because they are a torque to yield item. The tools we use to do something like this is a micrometer. We mic up the journal size, and then we use a bore gauge. This here is a bore gauge, so you set your bore gauge based on the diameter of your journal, and then you can set the bore gauge inside the bearing shells, and you can actually see how much looser or tighter it is at any given orientation, and that's how we record bearing clearances. It's the same process with rods. We do exactly the same process. However, when we do rods as well, we also use this when we're doing up the rod bolts. This is a stretch gauge. So this is the most accurate way to measure a fastener's tension. Simple torque readings can change with things like scatter. They're not the most accurate way to do it. If you could, you would measure every single fastener in an engine with a stretch gauge. However, given the nature of an engine and fasteners in general that are in engines, things like main bolts or main studs, or even head bolts and head studs, there's no way that you can get a stretch gauge on them. So the best thing we have is torque settings or rotational settings. So that's all we've got to do those sorts of fasteners. But the one fastener that you can get a stretch gauge on is a rod bolt, and so we always do rod bolts with a stretch gauge. Anywho, Rex is doing this while I'm working on another job outside the engine room, so I'll duck in every now and then just to film what he's up to and try and document a little bit of the process. But you know, once you've seen one, you've sort of seen it all, and it's just the same process over and over again for every rod and for every main. Right, so with the main clearances checked and all okay, it's now time to install the crank and check the end float. Not only does this set the end float, but it also sets the thrust. So your middle main cap is the thrust bearing as well, which is the bearing which takes the load of the crank moving forwards and back, which is usually from loading up on the back of the engine with the clutch or the converter if it's an auto. So what you need to do is align the two shells in the thrust bearing so that they're straight, because otherwise you can have misalignment in the cap and it can prematurely wear. It looks fairly barbaric, but it's what it do.
Cool. All the way forward.
Rods and pistons just starting to go back into this to complete the bottom end. So for those of you who don't already know, these GM fasteners, these are a angular torque to yield, which means that they're actually an angular torque. So we have this duva, which gives us an accurate angle reading. So the specifications will tell you to tighten down to a certain torque, and then from there it's 90 degrees, I think, on these, on 60 degrees.
It's 15 foot-pound, and then 80 degrees on the rods.
Yep. And same for the mains, and same for the stock GM head bolts as well. So another thing I should probably add that I'm assuming a lot of people are going to ask as well, is what bearings we use. Now, our pick of the bunch is Cleveite, which is Maloo. They're our favourite bearings to use. We reckon they're the best quality. So another thing that I'd like to touch on, which I know someone's probably going to ask as well, is why not change all to ARP hardware in the bottom end? So why we don't change to ARP hardware for all that is for two reasons. Firstly, it's just simply not necessary. You know, these stock GM hardware can take a pounding, they can hold a lot of power. These GM, the Gen 4 rods especially, you know, for what we want to do with this engine, ARP hardware is completely unnecessary, for one. Secondly, it presents another issue with tolerances. Now, going to ARP hardware changes clamping forces, and changing clamping forces on these parts can actually move them or change how round they are. So generally, if you're putting ARP hardware in things like rods or your mains, you want to get your rods resized to make sure they're within spec at the new clamping force, and you need to get your main tunnel checked or line honed or bored if it needs it, once again, to ensure that it's within spec with the new clamping forces. So it's just not necessary for us to do and not worth the money or the bother. So that's why we just buy new GM stuff. It's plenty strong enough and keeps things within a reasonable price.
Well, yeah, LS rods are a broken cap design. You can't resize them anyway. The other thing's cost. It's just, like what's a set of GM main bolts is like under $100 or something, isn't it? And ARP main studs are friggin' $500-600. It's a huge expense when it's...
Righto guys, so all rods and pistons installed, and it is now time to degree in our cam. As you can see, also cam installed, new dual row timing set installed. So always a good idea to degree in your cam, just to ensure that it is exactly what's advertised on the cam card. We have found that these Crow grinds, the off-the-shelf grinds from Crow, we've sort of never really had one that's been not as advertised on the cam card. They're pretty much always bang on. I think it's a lot to do with Crow's actual grinding process. It's all automated. You know, it's all sort of machine ground, I suppose you'd say, from the billet. So yeah, we've found them always to be pretty much spot on. But regardless, it's always important to check not only this, but also piston to valve clearance. So to do this, we have two lifters that are welded up. So these are solid. So there's no lash. They're welded solid, so that we can accurately check your piston to valve at what would your lifter be at full extension, I suppose. This way you get your complete extremity of your valve lift based on the cam, so you can accurately check your piston to valve clearance.
That's the TDC.
So sorry guys, I know that I'm really spoon feeding information here and going into a lot of detail, and for a lot of people it probably won't be that interesting. A lot of you probably might be very interested in it, in the in-depth process of what goes on. But if there's anything you can take from it, it's the time that it takes to actually build an engine this way and to properly do all these measurements and to properly blueprint an engine. Things like this, like a stock bottom end combo, are actually super good for us. Something like a stroker or something that's, you know, full aftermarket rotating assembly, it might go together and come apart 3-4 times. You know, it's not very often that you'll build an engine just once. It's very rare. A lot of it is work that gets done, undone, checked, and it takes a very long time. So this is why it costs a decent amount of money in labor to actually have your engine properly assembled and blueprinted, because it takes a freaking long time and it's a lot of work. Not only that, but a lot of specialty tools as well. So anyway, once we've got this data that we want to get, once we've confirmed the cam, degreed it in, and once we have confirmed that there's no piston or valve issues, this head will come back off. We'll finish the install of the springs on these two valves, and then the actual lifters can go in and it can actually start going together. After, we still have to CC a head. We have to CC a chamber so that we can work out exactly what the compression is, because I'm not sure how much Tremaniac takes out of the chambers when they CNC these heads. So we had 30,000 shaved off them. I think I've already been through it. But alright guys, so we've got our data that we wanted to get, which is really good because it is somewhat of a rarity to do a 6 litre with these, with cathedral port heads. So it is good to get the data for piston and valve clearance all the way around, particularly just because the cathedral ports have a smaller valve. So it's good to have that data. So another very important thing which I should point out is that top dead center isn't necessarily the closest point you're going to have piston to valve clearance issues. That's why it's important to do a really thorough check through the quite a long way of the stroke as it approaches and departs top dead center, because you will find that it's not necessarily top dead that's going to be closest. So be careful of that one, guys, if you're playing at home. Alright, so another thing that I should add as well, guys, is that if we do go to big cams when we're doing these things, your stock bottom end stuff, we aren't afraid to fly cut. You know, like I said, when you go into huge cams, you're really dropping that dynamic compression off quite a bit. And when you do that, you really need to get compression back into these things to actually make power. You see a lot of people go on huge big cams, as big as they can sort of go without fly cutting, and they don't really make the power that they think they will. And a lot of it's to do with the fact that either their heads don't support the flow of the cam that they've chosen, or they've dropped the dynamic compression too much and they just don't have enough compression to make the power, particularly if you're looking at going to E85. So we actually do have fly cutting tools. We do fly cut stock bottom end stuff with big cams to get comp back in it to actually make power. So anyway, like we stated, not a problem with this cam combination with the heads that we've chosen. This is all good. Alright guys, so sort of getting to the pointy end of things that I really wanted to document in depth and talk about, aside from just the straight up assembly. One other thing, the barbells that LS has used in the back of the block, we replaced them with Aeroflow billet aluminium units. They're just a little bit more staunch. Oh, stout. Crap everywhere. So we replaced them with that just because they're a little bit more reliable. The timing sets that come with all our cam kits, they come from Crow, but they're actually Rollmaster, and what they are is a Torrington thrust on the timing gear on the cam. So as you can see, the actual cam gear, it's got a little bearing. It's an actual bearing, see that? But you see the inside here where the bearing's actually pressed to the gear, it actually extrudes past the rolling surface of the bearing just a couple of mil. So to eliminate that rubbing or running against the cam retainer plate, which all of our kits come with a brand new cam retainer plate, which I'll explain in a minute, you have to chamfer the cam retainer plate to allow that to sit inside, basically in nothing, so it's not contacting anything, and allow the bearing to do its job. So as you can see, that's pretty much marked where it's going to be now. So we take a die grinder and we just chamfer that edge around just about 1.5 mil either way, just to make sure it's nice and well chamfered and that the actual gear doesn't run against the cam retainer plate. So all of our kits come with a new cam retainer plate, because as you can see, this is the oil gallery that feeds the cam and the lifters, and it's a very high pressure area, and the cam retainer plate actually has the rubber seal on it that seals that area. So we always put a new cam retainer plate on it just to make sure that this seal is good, because if not, you'll leak oil internally. It's another one of those oil leaks like that barbell at the back, where you'll never know that it's leaking because it's inside the engine, but you will have terrible oil pressure because of it. So the rear cover plate is also part of that same gallery, so always replace this gasket. Never reuse them, just because same thing, if it's leaking there, it's good. You're gonna have a terrible time. So we always recommend upgrading to, we sell a upgraded GM rear main plate, which is actually a new GM item that they replaced. It was to actually fix an issue that they had with the original backing plates on LS engines. So they come in this box. I'll open it and show you a look. So this is one of our upgraded rear cover plates. Now as you can see, they come already with your rear main steel installed and with a fresh gasket. And if you look at the size of the heads on the bolts, they're about the same size as a Gen 4 LS, but much bigger than a Gen 3. and you can see how much thicker that plate is than a regular stock rear main plate. Not only that, but it's also got a far thicker ridge on the bottom for the sump to bolt to, and this is actually different to even the Gen 4 rear main plate. So we always recommend these just because of the fact that the price of a new rear main seal and then a new gasket is more than half the price of literally just buying this kit all in one. So we always recommend just replacing the whole rear main cover with one of these. So these are also available on our website, and we pretty much put one of these on every single LS we do in-house here. So the next thing I want to talk about to note is, as you can see, we are going dual row on this engine. So all of our level 2 cut kits come with a dual row. We are going dual row on this thing, but when it comes to Gen 4 LSs, you do have to be careful because the dual row timing chain does interfere with, I think it's this boss here. I'll have to double check. But the front cover plate on the Gen 4s does require a little bit of clearancing. Not only that, but when you are doing a dual row timing set, it actually spaces the oil pump off of the block just a little bit. Now, when you do this, it is very important that you modify the pickup. So the oil pickup holes that actually bolt the oil pickup to your mains has to be elongated so that the oil pickup will meet the oil pump without any, I suppose, force trying to cock it either way. Now, it's sad how often that we see pulling down engines where people have gone to dual row timing sets and not done this and just tried to force the oil pickup tube into the oil pump, and it's a very bad thing to do, because eventually if that seal doesn't seal and it starts sucking air, you're going to lose oil pressure. You can come with all sorts of problems with this. So we'll show you that as well. All of our can kits come with new oil pickup O-rings. Now, we've got two different colors for Gen 3 and Gen 4. They are slightly different, and all of our can kits come with a new pickup O-ring. Always put a new pickup O-ring on your oil pickup tube. The last thing you want is for that O-ring to fail and start sucking air in the pickup tube. It's a terrible thing. We also have these oil pickup girdles. Now, I'll show you when this oil pump starts going on, but there are two bolts on the oil pump for the pickup. Only one is utilized from factory. So these are just a really cheap bit of insurance, particularly when going dual row, for that exact reason that I was talking about, because it actually physically moves the pickup slightly, and sometimes it's not done right, and this is just a good little bit of insurance to ensure that your pickup tube is going to stay nice and tight into your oil pump with your fresh O-ring, and it's always going to have good seal, and it's never going to start sucking air and fail and become a problem, because when that happens, you can pretty much say goodbye to your bottom end fairly quickly, and your top end as well for that matter. Alright, so another thing that can be fairly important to check is the alignment of the two timing gears, because sometimes they can be quite out of alignment. So it's another thing to check, just a straight edge without the chain across the gears. That boss, which is the bolt for the cam sensor, it needs to be clearance with the double row.
Yes, as you can see, the chain, that's where the sensor sits, and where the double row sticks out, it does hit that boss. So
it does need a bit of clearancing.
Yeah, and it doesn't go all the way through to the bolt hole, so you don't risk a leak as long as you're careful.
Anyway guys, you would be surprised how many engines we've pulled down that have been just tossed together like this. People haven't elongated the pickup holes, and the pickups have just been jammed in the pump. People haven't radiused the cam retainer plate, and the cam gear has just been eating at the plate. People haven't clearanced the timing cover and just put it on and bolted it together, and it's clearanced itself. The chains just ate away at it. We see some pretty wild things, so that's why I'm going it so in depth in this video. I know, so sorry guys, I know that for a lot of you it's probably not that good or that entertaining, but for anyone that's thinking about buying a kit off us and doing this at home, it's all very important information. Or for anyone who is maybe thinking about getting us to do it, you'll be able to see sort of how in depth we go of checking certain things and making certain things, or making sure of certain things, so that everything works the way it should be working. So you can see here the clearancing of the front cover. You can see Rex accidentally went a little bit too far and actually got the thread area for the bolt, so we just have to make sure we put a little bit of thread sealant on that bolt when we bolt the cam sensor back in to make sure it doesn't leak. But that's the sort of clearancing you need to ensure that it doesn't run along the chain. Righto, so time for the timing chain guide. All of our cam kits for Gen 4s come with the LS2 style chain guide that replaced the newer style one, because we just find them to be much better. This is actually a new one that we're trialing from our machinists. It's like a polyurethane CNC deal, which we're trialing. This is actually the first engine to receive it, so to suit your dual chain and everything, so I'm gonna give it a go. And these will be available on our website soon. Time for the oil pump install, which is quite an important thing that a few things need to be said about. So firstly, around the actual feed hole for the block, we use a little bit of flange sealant. This is Loctite 515. So this is a flange sealant that's designed to seal on very, very finely machined surfaces. Now you only need a very, very tiny amount of this. Now obviously with the double roll it comes with a spacer for the oil pump, so we put a little bit on each side. These are the spacers that come in the kit. They also come with new bolts in your double row timing kit. So another thing that needs to be talked about with oil pumps is that we don't just go slapping them on and doing them up. That's not how it works. Now there's no doweling. The LS oil pumps aren't doweled. And there's quite a bit of movement that can happen in the actual bolt holes that mount the pump to the engine. Now what that means is that the housing can move around a lot around about the center of the crank. So what we do is we use these shims. So these shims go on the inside of the inside gear, as you can see there, and to the outside gear to the pump. And what these these ensure that there is adequate room the whole way around the gears, around the pump housing. So what can happen is if you have the pump hard one way, you can have it hard against the gears on one side, and what this is going to mean is that there's no clearance to have your oil film around the gear on that side of the pump, and it's going to be wearing at the pump housing. It's going to cause all sorts of problems. So I often see LS oil pumps get a really bad rap. People reckon they cavitate, you know, they seize up and a few other things. To be perfectly honest, we have never pulled down an engine and seen oil pump issues that couldn't be attributed to an install error with either the pump or the pickup. As far as sucking air and cavitating and doing all sorts of funny things. So when care's taken and it's installed properly, we've never had a problem with these pumps ever, and they've always been rock solid for us. So with the shims in, you torque it up and then you simply pull the shims out and put the cover back on the pump. It's easy as that. So here you can see what I was talking about, where if these holes are where they're meant to be with the single row timing chain, because the oil pump's been spaced out by this spacer, it doesn't work. And we see all the time people just trying to force this in, and it's not a good way to leave it. So
it is not good.
We elongate these holes to allow the whole pickup to move forward about that much, so that it actually seats in the oil pump properly.
You'll find that this one here, this middle one, will have almost nothing left there, which it doesn't bother it because we put
it's
our
only
pickup
to hold the pickup up anyway.
Yeah,
we've got this one,
we got the good one
anyway.
at the back, and then you've got your double pickup brace, which actually holds the pickup anyway. So
this is one of our biggest issues with people doing cam swaps in car and putting a double row chain on and trying to leave the sump on. And what they do is they'll drop the pickup off the pump so that it can get all that off, do the cam swap, put it back on, and then just try and jam the pickup back up. It's just not the right way to do them. It shouldn't be done like that. So I'll just show you guys on this pickup. Some of these have them and some of them don't. At first we thought that it was just old school guys tack welding the pickup tube to that collar, because it is an old school thing to do. It's an old small block Chevy leftover thing. So, but some of the ones we've seen, they look very factory, so we still are unsure at this point whether it's a factory thing or not. But in either case, our pickup girdles, which are designed to hold this, they will not go over those welds. So you do need to grind these welds back a little bit to ensure that the pickup girdle fits if yours has one of these welds on it. So small block Chevs, the actual pickup's only pressed into that little collar. That's why it's a leftover thing to just put a spot weld on them to ensure that they can't just drop off. But the LSs are actually different. You don't need to put a tack weld on it, so that's why we're still not sure whether it's a factory thing or not. It's a bit weird. Now we do a lot of cam kits in car because it saves a lot of cost. It's one of the ways that we can do cam upgrades quite cheap and do a complete cam package in car. But what we have is one of these. Now this is a special tool, and these pads sit in your bonnet sills. And what that allows us to do is sit that bar in your bonnet sills with these, as you can see, they're like big wing nuts to jack, so we can sling up your engine by the engine mounts, jack that up, hang your engine off this bar across your bonnet sills, and then we can actually remove the entire front cross member from the car to remove the sump. And we do it in car. It's still quicker than removing the engine, but that's how you do it in car properly, so that you can modify the pickup and put it back on in a proper way. So you can see now with them holes elongated, the pickup bolts up where it should, and the sits completely flat in there with no pressure or no pulling either way. So brand new O-ring, a little bit of rubber grease to ensure it doesn't catch or stick.
you can see the old one. You can see how it's not round anymore, it's been flattened, so that's why we replaced them.
We never ever reuse these O-rings. For the cost of what the new ones are, it's just simply not worth it. So with that well a little bit clearanced out, our girdle.
Never mind that it's fucking just a little bit ugly, it's alright.
Girdle goes on, and as you can see, girdle utilises both threaded holes in the oil pump, which is just a little bit of insurance. We always Loctite these two bolts as well, and as you can see the design of the girdle there, the way it holds the pickup.
Just another small thing maybe to note is that I always leave these loose and torque up these two bolts first, so that you know that the it's this part here that's actually pulling it into position and is happy, and then you just use these to lock it where it is, rather than if you did them up first and had it pulled a little bit one way and you had a little bit of stress on it. So
alright guys, Bob's Yarny, one oil pickup installed, girdled, fresh O-ring. Alright, well I think we've sort of covered all the most important parts with this for now, as far as we've gotten. So I'm going to let Rex continue on with this, and I'm going to get started on our trunnion upgrades. So a lot of you guys know we offer two different trunnion upgrades based on your budget. One of them is a generic white box trunnion from Crow. This is a CHE. This is sort of the more upper budget version, which is just a little bit better design.
more upper budget, you mean the better quality, more expensive one?
Yeah, exactly. Better quality, more expensive. But as you can see, the grooves in the trunnion arm will actually work oil out into the bush. As you can see, they are sort of somewhat designed to ensure that the oil works its way out the bush through the trunnion arm, whereas the generic white box ones are not. They're just a straight oil groove line. And what we do find is that these will last a bit better because of the way the oiling system is a little bit better. And so we do put these on things that we know are going to be doing quite big RPM or have really loaded up spring pressures, etc., and really load up the trunnion. Don't get us wrong, the generic white box trunnion upgrade is still a great option. We're still using it in a lot of our own engines. It is just one of those things where you could expect, if you're going to treat it, if you're going to give your engine a hard time, you could expect to have to replace them maybe every couple of years, whereas these will outlast them. Anyway, first things first, we've got to press out all the old trunnions out of the rockers and get them ready to receive our new trunnion. So while I do that, Rex will go on with actually just getting the lifters and getting this pretty much finished off and back together. One thing I will touch on before I leave Rex to it is one thing that you all need to be very mindful of and careful of is these head bolt holes for LSs. Now these are what we call blind holes, which means they don't go through to anywhere. They're actually a sealed end of the thread. What this means is that if you have any water or any fluid or anything in the bottom of the hole and you try and tighten a bolt down into it, that fluid's got nowhere to go. And as we know, it doesn't compress like air does. And what we find is you'll pull threads, or we've even found on some of them, you'll actually pop the side of the block where the head bolt thread goes down. So it is absolutely imperative, super important, cannot stress it enough, that you make sure all of these holes are completely cleaned, completely dry, no debris, no fluids, and we do that just with an air compressor, blow them out with an air compressor, turn it over and blow them out, but it is absolutely very important that you do that. So this is our little setup for pressing the old trunnions out, as we have just a little bit of a spacer, which the old trunnion sits inside of, and then we have a little rod, which just presses the trunnion arm through and presses the bearing out. I use a drill press just because I find it way quicker than an actual press, and they don't need a huge amount of force. So this is what you're left with at the end of it, is just a completely empty rocker arm with no bearing in it, and that's what you want. And this is what the stock rocker trunnion bearings are. They are a needle roller bearing, as you can see, and what happens is over time they get sloppy and they start to walk out, as you sort of saw when we started pulling this engine down. And what can happen is once the bearing race actually walks completely out, you see all these little needle rollers in here, and I can tip them out into my hand, and that's what you end up with. You end up with all these little hardened needle rollers, which all will end up going all through your engine when this fails. If you're lucky, they'll just go straight down through the oil returns and just sit in the bottom of the sump, and you'll never know about them, which does happen. But as you can imagine, these are hardened steel needle rollers, so if by chance these happen to get caught up anywhere that they shouldn't be, i.e. between counterweights and main mains webbing and stuff like that, you can confidently say that this hardened steel needle is not going to be what wears. If this gets caught up anywhere it shouldn't be, it's going to start wearing things that it shouldn't be wearing. So that's why we like to replace them as a means of security. Not only that, but you can see here the stock trunnions are a lift limited trunnion. You can see there where they start to contact, there's only so much lift you can get with the stock trunnion. The new ones eliminate that. The new ones will spin all the way around if you want to. They are what we call no lift limiting. Now, there are a heap of trunnion upgrades available on the market. You will notice that both the ones that we offer are what we call an oil impregnated bronze bush, or a completely solid bush. They're not actually brass as much as people call them brass. They're not, but they're a solid bush. They completely eliminate the needle rollers. Now, there are a lot of trunnion upgrades on the market that are upgraded needle roller trunnions, and we personally don't like the idea of these. Obviously, you're retaining a needle roller. Although it might be an upgrade from stock, there's still a needle roller there, which is risky. The second thing is actually installing them. You've got 2 needle roller bearing races that you have to install into the rocker. Now, I've spoken to a few machinists about this, and ensuring that both those bearings are aligned perfectly is 100% imperative in the longevity of those trunnion kits. If those 2 bearing races are just a little bit unaligned, they're eventually going to keep working their way out or in and eventually cause damage or damage themselves. So that's why we're not a huge fan of them unless you have the means to ensure that they're pressed in perfectly aligned. We don't think they're a very good idea personally. So that's why we stay away from them. That's why we offer solid bush ones. All right, all pressed out, ready for a wash. So there you go, guys, getting through it. The instructions that come with these are very simple, very clear, super easy to understand. I like to use a little bit of engine oil to put them together. Little pair of baby circlip pliers, snap ring pliers. Anyway, I've left one here out, undone, so that I can just show you the difference between the CHE versus, this is the other one I was talking about, the generic white box one that comes from Crow. So this is much easier to install and work with because everything's floating. So the actual bush moves in the rocker arm as well as the trunnion arm moving inside the bush, whereas the generic white box ones, the bush is actually pressed into the rocker arm and only the inside on the trunnion arm moves. And you can see what I was talking about, the trunnion arm, how the grooves are straight. So they don't do as well as the CHE kit as far as actually working oil out through the trunnion and actually out even through this piece into the actual rocker arm. So that's pretty much the main differences, the key difference. Apart from that, they are C-clipped solid bush. Apart from that, they're very comparable, but this design of the CHE is just much better at oiling and therefore just does a lot better as far as longevity. So like I said, guys, this is pretty much the best you can get, the best in the business as far as we're concerned for a trunnion upgrade. Simply the best that you can do. This, again, better than a stock trunnion. If you're on a bit of a budget, still going to do the job fine. If you've only got a mild cam, you don't plan on giving your engine a real hard time, these are going to be fine. But you know, if you're putting in something that's fairly wild, like I had put these in my drift motor with this same cam that we're putting in this LS2, but I had expected that I would pretty much be buying replacement bushes to do replacements every 2 years or so. I expect that. So because these are pressed and they don't move around, what you end up having is wear on one edge as well. Whereas because the CHE ones actually move in the rocker arm and in the trunnion, you get a much more even wear because they actually move around while in operation. So you get much more even wear as well. So those are the main differences. I just thought I'd show you before I put the last one in. Oh, how good do those CNC ports look? So we've got our new LS7 lifters in here, come with all our cam kits. Really good value for money lifter, can't go past them when building an LS. We like to soak them before we install them to ensure that they've got oil in them. We don't like starting an engine with dry lifters. We don't believe it's a very good thing for them. Next thing to do is to actually CC a chamber overhead so that we can actually confirm what the compression of this thing's going to be. To do that, we use the stand that we've got, a burette, a little bit of plexiglass which we grease onto a chamber and see exactly how many cc's these chambers are.
I reckon. Just looking at that.
So we're just a smidge under 66 cc, it's about 65.5 cc's. So that actually puts the chambers just a little bit bigger than stock. So stock, these are 64 cc. 64.5 cc stock. and so we're about a cc bigger than stock. So that's with the chambers CNC'd and then 30 thou taken off. So it's a bit of a shame. We would have liked to see a little bit more, like a bit of a smaller chamber, a little bit more compression. But, you know, first time using these particular CNC'd heads, so we had no data to go off as far as what they do to the chambers. So it is what it is. It's still going to keep this thing at stock compression, which or fairly close to stock, which in LS2 is 10.9 to 1. So still decent enough compression. Won't hold us up too much. Still be fine. And again, perfect for boost later on if the owner decides to go that way with it. Be super happy to boost this thing. But yeah, that's where we're at. So this thing's getting ARP head bolts as well. Alrighty, so head's all torqued down. It's now time for our new 80 thou wall push rods. Couple of brand spanking new rocker stands. Yeehaw! Woo-wee! This is my favourite part. Fresh CNC'd heads. CHE trunnion upgrade, fresh double springs. It just looks so good. Looks so good, it's a shame to cover up. Now, one thing you do have to be mindful of, particularly when using these CNC heads, is that for a lot of programs, the CNC port actually will uncover the base of the thread for the intake rocker arm. So you have to make sure you put thread sealant on that bolt, otherwise what you'll have is it'll keep on drawing oil through into the intake port. Alright, and we're pretty well together. As you can see, we've got a new oil pressure sender. Hopefully this fixes our oil pressure issue in the dash. And yeah, super keen to see some results out of this thing. So with the engine assembled, that pretty much concludes this episode. Obviously from here it's now get it in the car over the weekend and ready for a tune on Monday. So keen to see some results. Sorry for this very long-winded episode, guys. I know, as I already stated, for a lot of you it's probably not that entertaining or anything else. For some of you it probably will be very, very good, very useful information. There's probably even a lot of people out there that are going to have a go at me for giving away trade secrets or whatever else you want to do. There's always someone that says something like that, but the way I see it is that you're always going to have hobbyists, you're always going to have people that want to do this work yourself.
I'm one of the ones that says that.
Yeah, Rex is one of the ones that says that I give away too many trade secrets.
Give away too much.
Well, the way I see it is people are going to do it anyway. You know, there's always going to be hobbyists, there's always going to be people that want to do this themselves. It's because they enjoy it. It's the same reason you're all watching this right now. So, the way I see it is gatekeeping this information is no real advantage. It's not going to stop that from happening. People are still going to do it anyway. So by giving people the tools to be able to make the informed decision of what to get, whether or not they possess the skills or the tools to do this sort of work to this sort of standard themselves, or whether or not, yeah, they want to do it themselves or send it to someone else. You know, I feel like giving them that information, allowing them to make that decision, it just going to elevate the quality of work that's done everywhere. So, you know, for us as tuners, we'd much rather someone bring us a car that they can themselves or did themselves and have pretty much a trouble-free day and have a good tune and they get a good result and everyone wins. The last thing we want is for people bringing us stuff where we have problems with it that we have to fix, it costs them money. Nobody wins in that situation, in my opinion. So anyway, if you are thinking about doing a cam in your LS or doing a rebuild or anything, hopefully this video shed some light on tools, things to use and buy, things to look out for and what to do, things to do the right way and things to definitely stay away from doing because they are the wrong way, and hopefully everyone gets some sort of value out of it. So anyway guys, hope you've enjoyed. Smash like, smash subscribe. We'll see you on the next one. Peace out, see you, bye.